Let's look at applying the Euler's theorem. Okay, let's look at a function u is equal to x to the power of half plus y to the power of 1 by 2 x to the power of n plus y to the power of n. Now what we have to do is we have to verify Euler's theorem. So which means that first we have to figure out whether it is a homogeneous function or not. So let's try to now rearrange it or bring it to the form in which we can say it is a homogeneous function. So let's divide, let's take x to the power of 1 by 2 common. So 1 plus y by x to the power of half, yes. And then again within this x to the power of n, let's take it common. So we are left with 1 plus y by x to the power of, here x and x, these two can be multiplied. So x n plus half times 1 plus y by x to the power of half times 1 plus y by x to the power of n. Now if you notice, we can say that x to the power of n plus half, and we can say that this is a function of y by x. So function of y by x, which means it is a homogeneous function of degree n plus half, which means that we have to show that x dou u by dou x plus y dou u by dou y is equal to n plus half times u. Now this we have to prove. So let's begin. U is equal to x to the power of half plus y to the power of half times x to the power of n plus y to the power of n. Now here we have to first find out dou u by dou x, then we have to find dou u by dou y. Okay, dou u by dou x is equal to what? In this is constant, so we can leave it out, and we have to look at x to the power of half. So this becomes, or rather we have to apply the product rule, right? So first what we will do is we will keep this as it is, x to the power of half plus y to the power of half, leave it as it is, and we differentiate this. Now here x to the power of n only we have to do. Okay, so we leave this as it is, x to the power of half plus y to the power of half, and we differentiate this with respect to x. So we have to only differentiate x to the power of n. So n, x to the power of n minus 1, y to the power of n is 0, plus now we keep x to the power of n and y to the power of n as it is, and we differentiate the first part, first term. So half x to the power of 1 minus half, which is nothing but half. No, 1 second. Now half minus 1. Yes, okay. Now let's do dou u by dou y. Now we have to differentiate it with respect to y. So x to the power of half plus y to the power of half remains as it is. This becomes ny n minus 1 plus half of y to the power of half minus 1, and xn plus yn remains as it is. We can change this half minus half. Half minus 1 is minus half. Half minus 1 is minus half, right? Now what do? We multiply this with x, because we have to prove this. This we multiply it with y, and then we add these two and simplify it to see whether we arrive at n plus half by n plus half times u. So let's multiply the left hand side, dou u by dou x with x, add this to y times dou u by dou y. Okay, now remember we are going to multiply with x, dou u by dou x. So x to the power of half plus y to the power of half n x n minus 1, since we are multiplying x plus 1 plus x to the power of n y to the power of n half x minus half, we are multiplying with x, so plus 1. Yes, now we are adding this to dou u by dou y multiplied by y. So x half plus y half times n y n minus 1 plus 1 plus half of y minus half plus 1 x to the power of n plus y to the power of n. X half plus y half n x n plus x to the power of n plus y to the power of n half x to the power of half plus x to the power of half plus y to the power of half times n y n plus half y to the power of half times x to the power of n plus y to the power of n. Now this and this, let's take it common out. This and this two terms we will take common out. So x to the power of half plus y to the power of half, if we take this, n is also common. Okay, so what is left? X to the power of n, y to the power of n is common. Similarly, half of x to the power of n plus y to the power of n is common, and what is left is x to the power of half plus y to the power of half. Now this and this are common, so n plus half times x to the power of half plus y to the power of half x to the power of n plus y to the power of n are common. Now this itself is nothing but the function u, so n plus half u, which is what we had to show as per the Euler's theorem. Okay, that is one. Let's take another one. Let's say u is equal to x to the power of 4 log y by x. Now remember, log y by x itself is a function, so which means in general we can say that u is equal to x to the power of 4 is a function of y by x. That function is nothing but log. So which means it is a homogeneous function of degree 4. So let's see whether it satisfies the Euler's theorem. X dou u by dou x plus y dou u by dou y is equal to 4u. 4 is a degree and u is a function. So let's see. What we have to do is we have to differentiate partially. So u is equal to x4 log y by x. So dou u by dou x. By the way, this can be written as x to the power of 4 log y minus log x. This is logarithm rules. So let's partially differentiate this. So x to the power of 4 remains as it is, and we have to differentiate log y minus log x. Log y is a constant because we are differentiating with respect to x. So minus log x, that is nothing but 1 by plus. Now 4x cube log y minus log x as it is. Dou u by dou y, if we differentiate with respect to y, then what happens? X to the power of 4, 1 by y plus, and this is a constant. So when we differentiate, we get 0. So 0 times everything is 0. So which means we are left with x to the power of 4 by y. Now what? Now x dou u by dou x plus y dou u by dou y is equal to x times this. So x to the power of 5 minus by x. So which means that this becomes 4 plus 4x4 log y minus log x plus y times x4 by y. So y gets cancelled. Minus x to the power of 4 and plus x to the power of 4 gets cancelled. So we are left with 4x to the power of 4 log y, and we reverse it. Reverse the log rule. So if we reverse the log rule, what happens? Log y by x. So this is nothing but the function u. So 4, which is what we had to show. Now let's look at the next one. Let's say u is equal to sine inverse of x square plus y square by xy. Again, we have to show that. Of course, this is a slightly different thing because trigonometry is involved. So show that x dou u by dou x plus y dou u by dou y is equal to tan u. We have u is equal to sine inverse of x square plus y square by x plus y. Now what do we do? First of all, working with the inverse trigonometric functions is tricky. So let's convert it into a normal trigonometric function. Let's bring sine to this side. So this becomes sine u x square plus y square by x plus y. This we know how to take care of. So let's take z is equal to x square plus y square by x plus y. Yes. Now you know we can write it as x square out. So 1 plus y by x the whole square divided by x common 1 plus y by x. Okay, so this goes off. So which means that we can write it as a function of y by x. So which means it is a homogeneous function of degree 1. Okay, so which means that x dou z by, because remember we are talking of z is equal to, so x dou z by dou x plus y times dou z by dou y is equal to 1 times z. So let's find this, multiply it by x and y respectively and add them. We know z is equal to what? Remember here we have said z is equal to this, but this in turn is equal to sine u. So which means z is equal to sine u. So now dou z by dou x is equal to what? We know cos u, and then we have to differentiate u itself. So dou u by dou x. Similarly, dou z by dou y. So cos u, dou u by dou y. Okay. So we have got dou z, dou x. So this we have to multiply it by x. This we have to multiply it by y. So this becomes x cos u, dou u by dou x, and this becomes y cos u dou u by dou y. Okay, so now we just add it. Now if we add these two, we get what? X cos u dou u by dou x plus y cos u dou u by dou y, which is equal to, remember, z, and z is nothing but sine u. Okay, now we are very close, but somehow here tan should come. So if tan should come here, that means we have to divide it by cos, which means we have to on the left hand side also divide everything by cos. Yes, divide by cos u. So we end up with x dou u by dou x plus y dou u by dou y is equal to tan, which is what we had to show. I think that's enough for today. Bye for now.